Welcome to week 0 tutorial. This is a demo live session for the course Introduction to Machine Learning taught by Professor Sudeshna Sarkar. I'm Pintu Kumar. I'm a PhD scholar at IIT Bombay. I would be taking a demo session today and would try to cover few of the questions from week 0 assignment. From next week onwards, we will have a full 1 hour tutorial session where you would be able to interact with me and probably clear your doubts. And I'll be also discussing questions from like previous year's course on assignments. So I think it would be useful for both of us. So let's begin with our first question. First question over here says, a busy student must complete 3 problem sets before doing laundry. Each problem set requires 1 day with probability 2 by 3 and 2 days with probability 1 by 3. Let B the number of days a busy student delays the laundry. Find the expected value of B. So this question, we are given with certain event and we have been asked to find the expected value of that random variable. So the event over here is like how many days will he delay his laundry. So the student has to solve 3 questions. Right? So for the first question, he will take some days. For second, he will take some days. So the sum of all these delays that he's doing would be RB. So let me introduce you to the concept of expectedness. I think most of you would be familiar with this, but anybody who has not done anything on probability or has not revised his probability concepts would find it useful. So let's say B is a random variable that takes values B1, B2, B3, and so on. So let's say it takes values till Bn, and the corresponding probabilities are P1, P2, P3 till Pn. Then the expected value of B that we would get is the sum of probabilities multiplied by their values that they're taking. So it is, in other words, it is summation Bi probability of Bi. So this is something that I've written over here. So this is what we are going to use to solve this problem. So there are a couple of options to solve this problem. So the first option, like professor has already given an example, like if the problem set requires 1 day to finish first question, second 2 days to finish second and third questions each, then the student would delay for B equal to 5. So if you look carefully, this B can take value from 3 to 6. So student can delay at least 1 day for each question or maximum 2 days for each question. So this B can take values from 3 to 6. So if you want to use this formula, what we can do is we can find probability corresponding to B is equal to 3, then probability B is equal to 4, and so on. And then we can use this formula, right? For example, the example that professor has mentioned that it will take 1 day to finish first question and so on. So to calculate its probability, we are already given that it will take 1 day with probability 2 by 3, and see that these events are independent. So if a person is taking some amount of time on first day, the amount of time on second day is independent of the first day. So we can find the probability of this sequence as 2 by 3 into 1 by 3 into 1 by 3. This is nothing but 2 by 27 that you can see. But there are other options that also can lead to 5. So it is like it is taking 2 days for first, 1 day for second, and 2 days for third. And similarly this option. So like if you go by this method, it will involve a lot of calculations. So you have to find for B is equal to 3, see what cases can be made, then B is equal to 4, see what cases can be made, and then finally sum it up and then use this formula to evaluate the probability. So there's another way we can do to make our calculation simple. So let's say we have random variables x1, x2, and x3, or we can have any list of these. Then expectation has a property that expectation of x1 plus x2 plus x3 till xn we can split these expectations. So we can find expectation of x1 separately, then expectation of x2, and then we can sum them individually. So here, if we look at B is the event, like so it counts for the time taken to solve question 1. So if you take x1 as the time to solve problem 1, and x2 as time to solve problem 2, and x3 as time to solve problem 3, then we can get the B. So this B random variable can now be represented as sum of 3 random variables, right? Now, as I mentioned, we can split them this way. Let's try to find one of these x1s, and we'll try to see what happens to others. So x1 is time to solve question 1. So time to solve question 1 can be 1 day or 2 days as per the question. So with probability 2 by 3 and 1 by 3. Now, evaluating the expectation over here is quite simple. So you can just do this calculation, summation xi into probability of xi. So 1 into 2 by 3 plus 2 into 1 by 3. It's 4 by 3. Okay. Now see that all the questions have similar distribution. So this x1, x2, and x3 are same distribution. So expectation of x1 would be same as expectation of x2 and would be same as expectation of x3. So the expectation of B that we get is 3 times the expectation of x1. So we have already evaluated this, so we can easily find our expectation of B. So this was the first question that I thought to cover. So there are 2 takeaways that you can have from these questions. First is that expectation of any random variable is summation 1 to n probability of I xi, where probability of I is nothing but probability of xi. So probability is sort of essential for the course to follow. So I would recommend you to just brush up your skills over it. Next thing that we saw here is like if x1, x2, and so on, xn are random variables, mind that these need not be independent over here. Even if these random variables are dependent, then expectation follows this property. This is equal to expectation of x1 plus expectation of x2 and so on till expectation of xn. One more thing just to mention over here is like if a is some real number and we have something of this sort, that ax1 plus x2, then it follows something like this, that it is a times expectation of x1 plus expectation of x2. So this is something that you can take away from this. Now let's come to our second question. So for the second question, the question is, suppose there is a sentence, let's play or not play. The bag of word representation for the vector sentence is the count of each word in the sentence. So bag of words is a famous representation for word sentences. So what we do over here is we list all the words that are present in the dictionary. So right now we are considering only one sentence. So we have just considered the words that has occurred right now. But you can imagine this as a very long sequence of word, where you list all the words that are present in the dictionary. And whatever word appear in that sentence, you mark the number of times that word has occurred, and you get a vector representation for that sentence. Okay, so let me reread the question. So bag of word representation of this sentence is this. So this is some point in your R4. So now suppose that there is some query vector, that is your Q1 is equal to 0, 1, 0, 0, and another query vector Q2 that is related to let's. So you can see that second position was play, so we have placed a 1 over here, right? So find the nearest query sentence. So now in terms of nearest, in hint we are given that we have to use cosine similarity. Okay, so although the word distance is mentioned over here, but cosine similarity is actually a similarity more than a distance. What I mean by that is, like, if your cosine similarity is increasing, then two sentences are more close to each other. So if you would consider the distance, if distance is increasing, then those two sentences should be far apart from each other. Like, they must not be related to each other. Now, the first question is, why do we need this kind of representation for words? Why is this kind of thing needed first? I'll try to throw some light on this. So when you will begin with the course, you will see, at least how I see machine learning is. So you have a bunch of vectors. So x1 is a vector, x2 is a vector belonging to some, let's say, Rn. So let me give you an example that you want to predict, let's say, weather. Let me know. Okay, so you want to predict rain on a certain day. Although this machine learning is not a very good idea to predict rain, but yeah. So you look at something like the temperature that was on the previous day, or the humidity that was on the previous day. You list a bunch of features. So this one feature correspond to a vector x1. So this one list of features correspond to this vector x1. So you take something like this. Okay, so this is your input to a machine learning model. Then you try to find a function f that can give you an accurate y, that is your amount of rain that would happen. So this is a very generic model that most of the machine learning algorithms follow. So this f, if you see, this f is taking vectors as input. So if you want to do something like natural language processing, so you might have seen Google Translator that translates from one language to other. So there you need to input sentences to this function. Now, how can you like input sentences to this function? There these vector representations kind of comes handy, right? So there are other places also where these kind of representations are there. So if you look at network data, okay, network data, that is your graph, something like nodes and vertices. So these kind of data you see very common in nature and even in like many applications. Here these kind of vector representations also become useful. Another thing is in recommender systems, these are highly used. So you will learn these things probably through this course, and even after this course, you'll explore and find this vector representation being very useful. Now, what's cosine similarity? I'll define over here. So let's get back to this question. So what's cosine similarity is? It's just the angle between two vectors. You might have studied this in class 11th, probably 11th or 12th. That this is just the angle between two vectors. So it is dot product of v1 and v2 divided by the respective norms of v1 and v2. Now let's first solve this question. What it says is we have a point S. I should have used the same notation, but our S is same as v. So we have a point V that is 1, 2, 1, 1, and we have a query point that is 0, 1, 0, 0, and another query point that is 1, 3 times 0. So we'll try to find this cosine similarity with both of these. So this is simple. This is just simple dot product. 0 times 1 plus 2 times 1 plus 1 into 0. So you get 2 on the top. And if you look at this vector, its norm is simply 1. So I've written 1 over here. And I've just skipped this norm of v because we have to just compare these two queries. So what's the point solving for this norm? So for the second point also, we can find this as 1 by v. Now, if you look at these two quantities, you can compare it. This vector s, or the v that we are using here, is more similar to the query point q1. to Q1. So you can probably take Q1. You would have already solved this exercise, I guess. So this was the question that was asked. Now, another thing that I wanted to mention over here is, like, why should one use cosine similarity? Okay, so like most of you might be from different backgrounds. So one thing you all would have definitely seen is what's Euclidean distance. So you would have done something like, so if you have 2 points, x1 and x2, and y1 and y2, so this distance is given by square root of x1 minus y1 square plus x2 minus y2 square. So like here also we had some points in some vector space, or here it is R4. So why not directly use this Euclidean distance rather than going for the cosine similarity? So the answer is, I'll just give you an example why this cosine similarity becomes useful. So consider that you own an e-commerce website and you want to, like, some people are buying stuffs from your website and you want to recommend some user what he should buy next. So when you visit Amazon, like if you go to any product page, so I'll just come down. So if you go to any product page, so you would see an option that people also buy. So something that people are buying along with this product, right? Or there is a section on the home page, mostly I see recommended for you, like what it is recommending to you. So even on YouTube, if you go, or the Netflix you would have used, so it recommends you movies that you should watch next. So most of the time you are in a mood that you can't decide which movie to watch next. Then you rely on this recommendation. They will also profit from it. Like if they are recommending you properly, you will watch more and use their service more. So for this kind of problem, so let's say we had 3 users on the website. So you just started your e-commerce website. It's not a famous one right now. So you have user 1, user 2, and user 3. Let's say user 1 during the period January to June ordered 1 pen, 1 notebook, and 1 book. Then he might probably be a student or something like that. Okay, so second user bought a TV, a radio, and some cream, right? So the second user might be probably a person who is buying more of a household kind of things. Third person bought 50 pens, 50 notebooks, and some 50 books, right? So probably it's someone related to academia only. He's ordering some bulk item, probably for his school or something like that. So he's buying this kind of things. Now just think for a minute that, like, if you want to recommend this person something, uh, what would it be? Like something that user 2 has bought in future, or something that user 3 will buy in future. So you know what user 3 bought in future, and you know what user 2 bought in future. So what would you be likely to recommend more to user 1? So we don't know what user 1 would do, because he hasn't bought anything. We want him to recommend something. So definitely it should be what user 3 bought. So it is like, if you see even the trend, he bought some refills for the pen that he bought, and then he used covers for these books, right? So it's more obvious to recommend this thing to user 1 than to recommend box of sweets to this user, right? So now let's look at the vector representation for this. It is similar to back of words. So it is 1 pen, then 1 notebook, 1 book, and this is for TV, radio, and cream. So these quantities are 0. We could have included box of sweets, refill, and book cover, but so for simplicity right now I'm ignoring, because those quantity would have been 0 only anyway. So for the user 2, the first 3 quantities, that is pen, notebook, and book, is 0, and the other 3 quantities are 1. Now for the user 3, similarly, I have created a vector out of it. Now if you look at the Euclidean distance between user 1 and user 2, it's something, it's not something, it's exactly root 6, right? So you take 1 minus 0 square, so it's 6 times 1 square, it's just root 6 that you have. Now, if you take the similarity between user 1 and user 3, what we get is 49 square plus 49 square plus 49 square. This is 49 root 3. If you compare these two values, then this value is more than the previous one, right? So what does this tell us? Like, this is the distance between two vectors. This is u3 and u. So if the distance is more, we should try and like recommend something which is at a lesser distance, right? So if we use Euclidean distance, it would recommend that we should recommend box of sweet to this user. Now, similarly, if we look at this cosine distance, the way we have defined it above, so the cosine between user 1 and user 2 is simply 0, right? And between user 2 and user 3, it's 1. You can do your calculations. So what does it recommend is that it should be riffles and book covers for this user. So this example is just to show that this cosine is more useful in this kind of situation. Okay. So these were the two questions that I thought I should cover in the demo session. This demo session will have more questions in the original session. Just to mention that this cosine similarity would always lie between 0 to 1. So this is like, you might know it from your class 11 to 12. This is cos theta, where theta is angle between both these vectors. Okay, so this should be between 0 to 1. And so now you would be like, why it should be between 0 to 1 and not minus 1 to 1. So you should think about. So like it should be like between minus 1 to 1 only, like if you allow negative entries also. So right now I don't have any negative entries. So if these two vectors are like perpendicular to each other, then you'll get 0. And if they are like between, like if they are very overlapping, the angle between them is 0, then we'll get 1. So here we can have a small correction. It should be between minus 1 to 1. But if you allow only like something like bag of words example, where you have only positive entries, then it will be between 0 to 1. So thanks for today. Hope to see you in the next live session.